We are still continuing with equivalent expressions. Today we will go more deeply into that, but first we need to do the review, and you need to determine which pairs of ratios are equivalent and explain how you know. So you need a problem and a sentence. Since you have 2 answers for each one, I'm going to give you about 6 minutes to complete these 4. Go for it. Okay, so how do I find whether or not these pair of ratios are equivalent? Who can tell me what I should do? Guys, we have done this so many times. Lucas? I think I know what you're saying, but I'm going to do it this way, which is similar. Yes? And what am I doing with those? So turn this one into a fraction and this one into a fraction. So that's basically the same thing. I could use fraction bars there, yeah. All right, so what would I do to 5 to get to 100? Times 20. And what would I do to 7 to get to 140? So are they equivalent? Yes. Guys, we've done this how many times? Way too many times for you to still sit there and look at it and be like, I don't know how to tell if they're equivalent. Yes, you do. We've done this. Yes, they're multiplied by the same number. All right. 2. I'm going to put the top one on, sorry, the small one on top and the larger one on the bottom just because it's easier for me. What would I do to 14 to get to 42? Times 3. So 15 times 3. What is 15 times 3? 45. So are they equivalent? No. 15 times 3 equals 45, not 48. All right. The next one, again, I'm going to put the smaller one on top and the larger one on bottom. 20 to 21, 105 to 100. What can I do to 20 to get to 105? Can I do anything to 20 to get to 105? Not evenly. Can I do something to 21 to get to 100? Yes. Not evenly. If I flip that bottom ratio around, they would be equivalent, but the way they are not equivalent. No. All right, and the number 4. 9 and 12, 60 and 80. Can I do something to 9 to get to 60 evenly? But that's not in the right order, so they're not. You can't just flip the ratio. You have to use it how they gave it to you. Make sense? Can I do something to 9 to get to 60 evenly, Jared? I can divide 9 by 3 and 12 by 3, and I get 3 to 4. Now, what would I do to 3 to get to 60 evenly? Times 20. And 4 times 20 is? So are they equivalent? Yes. Yes. You're doing the same thing to both numbers. Any questions? Good. Turn the page.
You have your vocab sheets. You don't have your vocab sheet. it wrong, number one. Raise your hand if you don't have it. Okay, the term for today, vocab sheet is equivalent expressions. We kind of talked about it, we just did it, but now when we're doing algebraic expressions, it's going to be a little bit different. So our definition here, if when any values are substituted for the variables, the results are equal. In other words, if I put a number into the variable and I get the same answer in two different expressions, that means that they're equivalent. There's a couple of caveats on that. Number one is you really should have at least two values that are the same. It's possible to have two completely different expressions where they find one spot where they meet, but you're not going to find one that finds two spots that meet unless they're equivalent. Okay? So while it's not realistic to test each expression for every possible value in the unknown, you can examine the characteristics of each expression in the different representations. So the three we're going to work through today, we're going to do a table of values, we're going to do a graph, and we're going to rewrite the expression using properties. Guys, that last one is a direct relation to when you get to algebra in either 8th or 9th grade, depending on if you get in the advanced track, and when you get into geometry. Geometry is actually 100% just about the steps you take to go from one thing to the other. So we're going to start off with two expressions, 2 times the quantity x plus 2 plus 3x, and 5x plus 4. The first thing you're going to do is actually complete the table of values for each value of x. So they're giving us a value of x, and literally all it's saying is I'm going to take this value, and I'm going to substitute it into the expression every time I see an x. So everywhere I see an x, it's now going to be a 0 for this first line. Order of operations still takes precedence. So all I'm going to do is I'll show you the first one. So I'm going to go 2 times the quantity of 0 plus 2 plus 3x. 3 times 0. Okay? First thing I need to do is parentheses. So I'm going to add those. So 2 times 2 plus 3 times 0. And now I have multiplication going left to right. So I'm going to multiply this one first. I'm going to multiply this one second. And the final step is I add them. So what does this equal? 4. You now have all the work showing you what to do. Guys, I've given you a lot of room on the side over here. And you've got all this blank space over here to show your work. The second one is actually really easy because it's just two things. So I'm the same process. So I'm going to substitute the 0 in for the x value. We follow the same order. Multiplication before division. 5 times 0 is 0. 0 plus 4 gives me 4. So you do that for all three values. And then you're going to try to answer parts A and B. So this whole thing should take you all about 4 minutes. Good start.
All right, for the next one, what am I substituting x for? 2, 1. So all I'm doing is putting it in the problem where x is. What does 3x mean I'm doing? I am multiplying. It's not 31, it is 3 times 1. Make sense? All right, so parentheses, 1 plus 2 is? Come on, guys. 3 times 1 is? 2 times 3? 6 plus 3? 9. All right, and the next one. Again, I am putting 1 where x is. What does 5x mean I'm doing? Lucas. It means I'm multiplying, so it's not 51, it's 5 times 1. So what is 5 times 1? 5 plus 4? Any questions about those two? All right. The next one, what am I substituting x for? 2. So I put it in the problem. So parentheses, 2 plus 2? 2 times 4. 3 times 2. 8 plus 6. 14. Any questions about that one? No. Guys, you're using the order of operations every time. So 5 times 2? 10 plus 4? 14. Somebody's lunch is in the office. Okay.
Sorry?
Latte's lunch is in the office. All right, and what are we substituting for the last one? 3. So 3 plus 2? 5. 2 times 5? 3 times 3? 10 plus 9? 5 times 3 plus 4. What is 5 times 3? 15. 15 plus 4? 19. So what do you notice about the values in the table? What can you determine? They are equivalent. And what do you need to verify if the expressions are equivalent? What did we do each time? What did we do in each problem that was the same? Substitute the variable for the same number. And then we ended up getting the yes? Didn't we do that every time? All right, next page. I'll give you about 30 more seconds to write this. Those of you that have finished in turn. All right, on the next page, you have a graph. And you are going to graph the results from the table. It says, consider your completed table of values from question 1. Plot the values for each expression on the coordinate plane and then connect the results for each with a line. You want to do this one?
So guys, if you're going to draw a line, what do you think you need? Say that. I have one. You can grab a ruler. I'll plot the first one for you just to make sure. And then you can get the line. So here is my x value. The other two are my y. Two different y's, but they both use the same x value. So what that's saying is when my x is 0, in other words, I haven't moved anywhere, for the first point, I'm going to go up to 4. Make sense?
Oh.
Okay? You're going to do that for each set on the first one and draw your line. Then you're going to do the same thing for x, all the y values on the second set, and then draw a line. Then see what you see. You should have realized really quickly as I went through my values. My next one was 1, 9. So I go over to 1, up to 9. Then I go 2, 14, over to 2, up to 14. Then I do 3, 19, over to 3, up to 19. We then use our ruler or straight edge so that we can draw a line. And when you do your line, you should have seen something like that. Okay. Now, I do want to point something out. Actually, we do the second one first. So when you did your second set of points, I'm going to change the color just so you can see that it is different. So 0, 4, that's going to go there. 1, 9, that's going to go there. 2, 14, 3, 19. And what do you notice when you do your second line? Use a different color. So you can see, same one, right? So what does that tell you about the two expressions? They are equivalent. So what that tells you is they are the same line. So they are equivalent. But then we just do a whole bunch of exercises. Then we go to origin equivalent. So what's the difference? I just said these are equivalent. What do you think?
Maybe the origin is 4.
I'm sorry?
Maybe the origin is 4.
The origin is for something specific about the line. We said they were equivalent ratios. So if it's a ratio, equivalent ratio, then it's going to go through 0. But this one is not an equivalent ratio, but the lines are equivalent. You see the difference? I want to make sure you don't get confused between those two. Does that make sense? So they are equivalent because it's the same line. Now, guys, this next part, we're giving you a preview of high school algebra and geometry. The reason is, when you are doing high school algebra, you have to be able to justify every step you do. Normally, you start with, and what we're doing, rewrite the given expression, identify the property applied. So, when they give you a problem to start with, that's what we call given. So, the way we write mathematically, we just say given. That's what I started with. We then have to say what we are doing, what mathematical properties we're using as we go from one step to the other until we get to our final answer. So, for the first one, we always follow Gemma, right? So the first thing I need to do is this parenthesis, right? But can I actually do anything with the parenthesis? Can I add x plus 2? No. No. Then I go to what? Multiplying. Well, I'm multiplying this times that quantity, right? So that means I have to take that out. What do we call that? Distributive property, right? I'm taking it over outside. I'm distributing it both inside terms. That is distributive property. So that is our mathematical justification for the stuff we're doing. So 2x, we already said that. What's 2 times 2? 4. And then anything we haven't done yet, we just bring down, right? Our last step, and this is what we did on our homework last class, combining like terms using addition. So my like terms, the ones that would have the same algebra tile, same color, right? 2x plus 3x would give me, so I'm adding 5x. Can't do anything to the constant because it's a different type of term. So that becomes 5x plus 4. So going back to our table, what do you realize? What can you see? We just said that this is actually what? 5x plus 4. What was our other one? 5x plus 4. So what do we actually see now? It's when we simplified this, when we simplified the first expression, it became the second one. In other words, it was written exactly the same. So when we have an expression that's in pieces, and we're comparing it to one that's in simplest terms, a lot of times we just simplify the first expression to see if it actually simplifies to the same thing. If they simplify to the same thing, what do we know? They're equivalent. Make sense? But the big step for today is using these properties to mathematically demonstrate how I'm moving from one piece to another piece as I simplify. Any questions on this page, guys? Okay, let's go to our next page. Oh, that's a blank one I just put in there for some reason. So now we've had some practice. So now we're going to give you two expressions, 2x plus 5 and 2 times the quantity x plus 5. Complete the table of values. And then use the table of values to sketch the graph. Oopsie. I have to read something from last class. I should tell you something. So you just saw a preview of what you should see. Although I kind of made a mistake last class. Make sure you're using the correct ones. So the first expression, you're supposed to plot that one using squares. Second one, you're supposed to plot using triangles. And then once you've done that, rewrite the expression. That's the part we just did. So tell me the steps you're doing with how you're getting from one to the other. So we're going to give you guys about 10 minutes. We want you to do this whole page. So you can do the table values, you're going to stretch it, you're going to simplify the expression, and then you're going to make your conclusion about the equivalency. Okay, our first one, again, all we're doing is substituting the value in. So that becomes 2 times 0 plus 5. Multiply before we add. 0 plus 5 gives me an answer of 5. 2 times the quantity 0 plus 5 does change it. Because now I'm doing that quantity first. 2 times 5 gives me 10. That's a 10, 0, not an 10. Okay, then we do 2 times 2 plus 5 gives me 4 plus 5 or 9. On this side, 2 times 2 plus 5, parentheses first, 2 times 7 gives me an answer of 14. On this side, we've got 2 times 4 plus 5. So we go 8 plus 5, which gives me 13. On this side, we go 2 times the quantity 4 plus 5. Parentheses first, 2 times 9 gives me a total of 18. On this side, we go 2 times 5 plus 5 gives me 10 plus 5, or 15. On this side, it's 2 times the quantity of 5 plus 5, or 2 times 10, which gives me 20. We then go through and we start plotting our points. Our first one goes at 0, 5. Then we go 2, 9. Guys, stop the chatter. Then we go to 4, 13. David, stop talking. Then we go to our next one. We go 5, 15. Once we have them all plotted, now you pull out your straight edge. And we connect our points. So we go basically right through there. Our second set, this one is different. So we're going to use a different color. I've got 0, 10. So starting up here. Then I go to 2, 14. Then I go to 4, 18. And then finally we hit 5, 20. Let's be right here. Again, we connect our points using our straight edge. And this time you can see, do we have the same lines? No, this time the lines are different. So what does that tell you? What does the graph tell you, guys? They're not equivalent. They're completely different lines. Okay? And again, the whole key is, if they went to origin, we know they read ratio. meaning that the points would have been equivalent. This is two different lines though. This time the lines are not equivalent. Now we're going to use the distributive property to rewrite the expression 2 times x plus 5. So that means I'm just going to take the 2, I'm distributing it to each of those inside terms. 2 times x gives me 2x. 2 times 5 gives me 10. I go back to my value table of values. This becomes 2x plus 10. Is that the same as 2x plus 5? No, what's different?
Pay attention.
What's different? The 5 and the 10, what's the mathematical term for those? Constant. Constant. The 2 is my coefficient in the algebraic expression. The 5 is the constant. So they are different. They have a different constant. They are, trying one thought at a time. They are different. They have a different constant. So the term, the part of it that doesn't change is different. The variable piece is the same. The coefficient on the x is the same. But because the constant is different, it means there's different lines. No, that's all right.
Oh. I already took yours away. You have it back? No. Put it back on the table. You can just rough your.
Okay, let's go to the next page. You've already done all this, so now's your chance to show us you're understanding it. We've given you two different pieces. We want you to build a table. We're going to have you do the reasoning second, and then you're going to graph it. So we'll give you guys about 10 minutes to finish off this entire page. Go ahead and start. First part on it, you have to substitute each part. Where you're putting the substitution, that 0, everywhere you see an x. Okay? So it goes in all of those different spots. So this now becomes 0 times the 0 plus 3 times the quantity of 2 times 0.
Stop talking.
Plus 1. Then I close my parentheses. Order of operations. Within the parentheses, I still follow order of operations, or gamma. Meaning I'm going to multiply that first. So 0 plus 3 times 0 plus 1. Those still get added together. 0 times 3 plus 1. Now we do multiplying before we add. 0 plus 3 gives us an answer of 3. The second one is super easy. 7 times 0 plus 3. Multiply first. 0 plus 3 gives me 3. We do our second substitution. Now we're doing 1. So 1 plus 3 times the quantity of 2 times 1 plus 1. Following the order of operation. 1 plus 3 times 2 plus 1. I know you weren't talking last time, which we felt you were. You're not talking again, CJ. Please be quiet. The recording is right here. Stop. So now we add the 2 plus 1. 1 plus 3 times 3. 1 plus 9 gives me 10. 7 times 1 plus 3. Multiply before we add. 7 plus 3 gives me a total of 10. And your last one, now we're doing 2. 2 plus 3 times the quantity. 2 times 2 plus 1. 2 plus 3 times 4 plus 1. 2 plus 3 times 5. That's a 5, not 15. 2 plus 15 gives me 17. And the other side is just 7 times 2 plus 3. 14 plus 3, which gives me 17. Our steps. What am I doing here? Distributive property, yes? So the first thing I need to do is distribute that out. Guys, I'll give you a huge hint. This is going to be a major part of your homework. Hope you understand how to do this. Make sure you get the terms down. So that becomes 6x plus 3. Now we're going to combine like terms, the whole piece of our homework last time. And in this case, we're using addition. So I need to put the pieces that are together the same, the x and the 6x. If I don't see a coefficient, what is it? 1. 1 plus 6 gives me 7x plus 3. What do we notice? Same thing. So it's the same expression. So what do you expect when I start plotting them? At 0, it's 3. At 1, it's 10. At 2, it's 17. When you plot them, you should see that my lines are exactly the same. There's the first set, the second set is going to go right over top of it. It's the exact same points. So are they equivalent? Yes. Do I have to use all three formats to show that they are equivalent? No. Any one of those three will show you that they are equivalent. We're giving you three different options to show are my two expressions equivalent. Does that make sense for everybody? Questions on any of those? Good. We need to go to our homework at this point. So let's go ahead and go to page 395. 397, sorry. Okay, explain what it means for two algebraic expressions to be equivalent. This should be one of the easiest journal entries ever. We just gave you three different ways to show it. Determine whether each pair of expressions are equivalent. Properties, a table, and a graph in each problem. So, you have to do all three? Yes, because the directions say to. The directions didn't say to. You can prove equivalence in any one. They gave you the graph and the table. They did not give you the properties like they did before. So make sure you've written out the property step. I'll give you a hint. It starts with given. Then you're going to have two steps. This is the one you're going to need to use in order to simplify that expression. And your last page, you're doing the same instructions. So I have to use a table, use a graph, and use your written out. So I need three steps. Again, it's going to start with a given. And your given piece is actually going to be this one this time, not the first one. This one's already simplified. You got to simplify the one that's not simplified. Any questions on your homework? Guys, it's just like what all three pages we just did. So you're going to figure out if they're equivalent or not based on those properties. Good luck.